one. If I solve this for y, what does that give me? Something. A line. So, I have a parabola and a line. How many times can a parabola and a line cross? Once, twice, or none. It can cross no times, right? If my parabola goes up here and my line goes down here anywhere, and here's my line, it could cross no times, no solutions. Now, our goal is to solve these, and we're going to solve them algebraically. I realize you can put them in your graph, and you can solve them in your graph and take a look at them, and that might be a good way to check it and see how many solutions do I get. So if you put this in your y1 and you put this in your y2, do it, go back to your standard graph, and see how many times that line crosses. So if someone can do it for us, I'll grab a calc. Do a zoom 6, so you're back to a regular graph. Just so we can see how many times it crosses. So you're getting a parabola that looks like this. 2 times, good. And you're getting a line that's going through here, right? So we can see that it's going to cross 2 times. Now, algebraically, we have a few different ways to do this. One of the easiest ways, especially since you put it in your calculator already, is to set the y's equal to each other. You have elimination, you have substitution. This would be a substitution. Substitute for y. Or just make your y's equal each other, if it's possible. If it's not, sometimes we set them up, remember setting them up top and bottom and adding them together to eliminate one of your variables? You can only solve one equation for one variable. 2 equations, 2 variables. Your goal is to eliminate one variable into one equation. So we have a couple of ways to do this.
And for the second one, would that x be negative?
I'm going to add x to the other side.
Oh.
I'm going to add x. I need to get y by itself.
Yeah, okay.
This one I added y, but then I subtracted 1. Now, I could do this. Let's look at this a few different ways. This is actually a substitution way. I'm substituting in what I found for y, and because my y's have to be the same number, don't they? My x's have to be the same, my y's have to be the same. I can solve for this. Now, here's another issue you guys seem to have. When you have a higher exponent, an x2, a square, you have a descending variables. Everything has to get to one side. You can't cross any variables out. You've got to get to your quadratic. So we're going to subtract x, add 1. Your goal to figure out where they cross is to find their solutions. Set them to 0. X squared minus 2x. And what happens to my 1's?
Gone.
Gone. Now, I can't set this as a trinomial. I don't get 2 sets of factors, but they have a factor in common. What's their common factor? What do they both have? X. So factor out an x, and what's left? X minus 2. This is where, just like you did with your trig, you set them both equal to 0. So x was equal to 0, and x is equal to 2. Now, notice, you found 2 points, but a point on your graph is an x, y point. So we did find 2 pieces of x. Oh, we can see it's probably crossing there and right around the 2 somewhere, but you got to find its y. So we bring this down and we substitute in. We substitute your 0 in, and we get y equals -1. So here's one of our solutions. And I'm going to have you check this on your calculator in a minute. Then we do the same for this guy. And we substitute in this too. So y is equal to 1. So here's your other solution. And we saw on your graph that you had 2 solutions. And if you check in your table at the 0, -1, you should see 0, -1, -1 when your y's are the same. If you look at your x equals 2, you should see 2, 1, 1 where your y's are the same. So we found your solutions graphically, but our goal is to find them algebraically. That's one of the easier ways. By substituting, you can also do it a couple of different ways. Are you okay with this? We set them equal to each other. Because once you solve for y, I find it this way. If I'm going to put it on my calculator and set y equals, I'm going to set those y equals to each other. Because that's easier. I've already put them in y equals. I wanted you to put them in y equals for you to graph them. But you don't always have to graph them. So I'm going to show you another way in just 1 second if this one's okay with you. This okay with you? Okay. Another way, you have a bunch of ways. You can substitute this. Solve for y over here. Get x by itself, just this one. Then, when you see this y, substitute that in there. That's another way to do this. Substitute in. I had you do y equals for a reason, because I wanted you to see it on your graph. But if I'm not asking you to graph, maybe you just want to do this. Now, you need to be careful, because that negative sign sits outside of this whole thing. So now we distribute. We get -x plus 1. We get everything to one side. We combine these. Isn't this where we were before? X squared minus 2x equals 0? Same place. We were at the same place before. That's your substitution also. Okay with that? Now, third way, elimination. Sometimes when you line these up, you can add them down to eliminate one of the variables. So I'm just going to write this so that we line them up. This guy is a negative x, I have no x squareds, plus y equals -1. There's your adding them to eliminate.
Oh, this is elimination?
This is elimination. If I add these two lines together, won't I eliminate the y's?
Yep.
So I'll get x squared, add these down, minus 2x, oops, that's equals 0. Aren't I to the same place? To the same place as before? So it doesn't matter which method you do, whatever method you find works best. If you're going to graph it and set it to y equal, I like the y equals to set the y's equal to each other. But if you're not graphing them and you just want to substitute them in, you can substitute them. If you can line them up, you can eliminate them. And then, continue, find your x's. The one thing you have to remember is you have to go back and find your y's, which is why I like to have my kids graph them, because this way you can see, oh, I got an x, comma, y point over here. I'll never forget, quite a few years ago when we did the Math A and the Math B, I had a kid on the Math B Regents get a 99, and as soon as he walked out of Regents, he found me and he said, I know what I forgot to do. I forgot to find the y values. And I hadn't looked at the Regents. So when I was grading, we were grading them, he got a 99 because he forgot to substitute back in and get the y values.
So if he did that, he would have got 100.
He would have got 100. Yeah.
I'm done.
Yeah. So I kind of showed you like 4 different ways. One graphing, one y equals, which is really like a substitution, another basic substitution, and an elimination. Now, it's best to eyeball them. Like this guy, which one would you use for this one? Would you want to set them equal to y? No, because you got a lot of fractions. Elimination. I'd want to add these and eliminate these. Now, if I go to add these, do I actually get rid of one when I add them down? No. So do you remember what you had to do last year, or the year before, actually?
The conjugate.
Not the
But I mean-
conjugate. No, we had to find something in common. We had to make these be the same but opposite signs. Now, this guy has opposite signs already. So if you add a positive and a negative, it should cancel out, right? But we have to make them the same number. So what can I multiply by 3 and multiply by -4 to give me the same number? I can multiply this guy by 3. What would you multiply this one by, Aaron? Well, I want them to be opposite signs. 4. So if Aaron multiplies this by 3, we find a common multiple. Between them, they have 12 as their first common multiple. So if I multiply this by 3 and I multiply this by 4, it should be able to cancel out. Now remember, you're multiplying every term. So this is going to come to 20x plus 12y equals 36. And do your bottom line. 6x minus 12y equals 42. Now, when I add them, don't I eliminate the y's? That was your goal. So I get 26x is equal to 78. I divide by 26, and I get x is equal to 3. Then what do I have to do? Substitute back into either one of them and find my y's. So I'll take the first guy. I substitute this back in. Because now I get rid of one variable and I only have one more to find. So 15, I subtract 15, you with me? And I divide by 3. So I've got a pair. Remember, I've got a pair here. Both of these made what? What would they look like if I graphed lines? They made a line. Both of them were lines. So either they can cross once, they can actually sit and be the same line, or they can cross no times. So I'm actually finding one solution. They cross one time. There's my solution. Now, I definitely wouldn't solve for y, because then I've got fractions all over the place. I have to multiply through by a common denominator. I mean, the bottom one, you're still going to get fractions on all of them, actually. So, I think elimination, when you can see them line up like this, is the easiest way to go.
So if you substitute the other one, it would be the same answer?
If we substitute the other one, would have got the same answer. So this guy's actually a good one to check now. So if you want to check that you're right, do the one that you didn't use. So take this one, and now substitute in your x value and your y value, and see if they add up to that. So I've got 6 plus 8, and yeah, they check. Whatever one you didn't use, you can check with the other one. And I wouldn't want to graph this, because I'd have to set them into y equals. Good? Remember doing these? Like way back? Probably Algebra 1 you did this, because I know we didn't do this in Algebra 2. Algebra 1. I don't know that you did it in geometry either. So, even though you worked with some lines and things, probably just Algebra 1. Yeah. Okay? So let's try another one. Okay, thank you. So, what method would we use for this?
Equal.
You can stick to elimination on this. What's another one you could use for this? That's elimination. Substitution. Which one would you solve, Vanessa? Which one would you want to solve?
The x minus 2y equals 3.
Yeah. If you solve this for x, so can't you add 2y? And then substitute it in here. That's a substitution. You can do that. Or line them up.
Would it be minus 1?
I'm sorry?
It wouldn't be minus 1?
No, I solved for x. So I added 2y to both sides. I covered the minus sign so it looked like a plus. That's what happened. When I put my red line there, it covered it up. So if you want to do it this way, line these guys up. Now, I noticed that they're both opposite signs. So if I can get a common factor, a common multiple between them, I can eliminate. What would you like to do?
Wait, you can do the y.
Multiply which one? Wait, I'm sorry, Vanessa, 1 second. Multiply which one? The top by what? 2? Okay, if I multiply the top by 2, let's see what happens. 2x minus 4y equals 3. And I've got negative 2x plus of 6. Thank you. Now, let's add these together. Oh, they all cancel. So I have 0 equal to 7. Is this true? No. So when this is not true, what happens?
No solution.
There's no solution. There's no solution. Now, watch why there's no solution. If you solve this for y, and you bring this over here, I'm just going to solve this for y. Negative 2y is equal to negative x plus 3. Divide by negative 2. I'm going to pull out your slope. I'm just solving it for y. Solve this guy for y. And I'm going to divide by 4. Look at your slope. Look at your slopes are the same, but your y-intercepts are different. What kind of lines do you have? Parallel lines. So parallel lines will never cross. Now, this is a good example of no solution. No matter which way you do this, you'll get no solution, substitution, or this. What was your question? I'm sorry.
Oh, because like with the other ones, when you circled the middle, I wasn't sure if it was supposed to do both of them.
When you multiply across?
No, when you did like the
Oh, yeah, you can actually choose either one. In this case, it didn't matter. You were going to multiply both by 2. That's why I asked Rachel which one do you want to multiply, the x or the y.
Like how you know how?
Oh, well, the easiest one to set up, I would first go for the one that's a plus and minus, so I never have to multiply by a negative. But this one just happened to be, they're the exact same, so it doesn't really matter in this one. But most of the time, this will say like a 3 and a 4. So I would do the easiest one. If I just can multiply one of them, that's all I need to do. If I have to multiply 2, then that's my decision on which one to multiply. But this one just happened to be that they were both going to turn out the same way. So it didn't matter in this one. Yeah, it didn't matter. Like if I gave you this. And I said to you, which one do you want to eliminate? I would go for the x's, because all I have to do is multiply this by 2. If I'm going to multiply here, I have to multiply the y by a negative 2. So I would just rather say, oh, it's so much easier. This is opposite signs. Just multiply this by 2. Does it matter which way I go? No. I still get the same answer.
So you did the top and bottom by 2?
What? In this case, I would only do the top by 2. That's all I needed to do was to make this match and be opposite signs.
You only need to do it with 1.
1. Because this one was a 2, negative 2, that would become positive 2. They would cancel out. If I can only get away with doing 1, I'll do 1. Okay? And now, another one that happens also is, say that you come all the way down, and you come down to this. 7 equals 7. Then you have all solutions. That means that your line is the same exact line. It falls right on top of the other one. Okay? I don't know if I put one of those in there, but... Alright, let's have you guys solve this. It's the same one? Oh, it's the same line? You told it ready? You can tell it ready? You divided by 2. Trey took the shortcut. Trey, what made you see that it was the same line? Oh, you already solved it. Okay, just by looking at that. Okay, put your pencils down a second and just look at those two things. This tells me Trey found that they were the same line. But, Jana, look at those two equations. What tells me? Kyle, what do you think? Shh. What do you think? What did you say?
Well, we didn't say salsa.
Multiply the top by 2.
Oh,
Or divide the bottom by 2. If I multiply this guy by 2.
it's a mom. No.
Ah, that's the same exact problem, isn't it? Yeah, or divide everybody down here by 2. No, actually you didn't have to do that, but you solved it and you found out it was the same line, right?
That's what I'm
Yeah.
So
Well, if you spot it like this, you can leave it like that. If not, let's solve it the long way. Let's solve it. Say I don't see this. I'm looking for these multiples to be the same. So what could I multiply by to eliminate one of my variables?
Let's just do like a negative because it is 6 on.
Okay, so one of them I have to multiply by a negative. So what should I multiply the top by? Negative 2. So this is going to give me negative 4x plus 2y equals negative 2. Agree? Now, do I have to do anything to the bottom? No. Now, I add them all together, everything cancels out. This is a true statement, isn't it? 0 equals 0. If it's a true statement, then I have all solutions. All solutions in this case, because they're both lines, means it's the same line. Now, if you spotted it up front, Kyle said multiply by 2, Couple said divide by 2. Therefore, I know it's the same line. And my answer is a little quicker, but that is absolutely fine. So we looked at a few different ways to solve this. Substitution, set your y's equal to each other. I would not want to end up with fractions unless I really, really had to. And I'm sure you feel the same way because I know how you love fractions.